if y is equal to sine k, k is equal to u squared plus 5 minus 1, and u is e to the 2x, then what is the value of dy over dx at x equals 0? Here we have three functions. Y is in terms of k is in terms of u, and u is in terms of x, right? So for the first function, y is equal to sine k, we can differentiate in terms of k. For this function right here, we can differentiate in terms of u. For this function, we can differentiate in terms of x. Then we'll be able to find dy over dk here. From here, dk over du. From here, du over dx. And if we multiply all of these derivatives, then that's going to be equal to dy over dx. So dy over dx is equal to, we can write dy over dk times dk over du times du over dx. This is equal to, what's the derivative of sine k? That's cosine k, right? So cosine k times derivative of u squared plus pi minus 1. Pi is number, right? So that's just the 2u. 2u times derivative of e to the 2x. That's exponential, so we must have e to the 2x times, by the chain rule, derivative of 2x, which is equal to. Now, since we are looking for the value of dy over dx at x equals 0, when x is equal to 0, u is e to the 2 times 0, which is equal to e to the 0, that's 1. And k is equal to u squared, so 1 squared plus pi minus 1, that is equal to pi. So dy over dx, when x is equal to 0, is equal to cosine k. The value of k is pi, right? Pi times 2 times u. U is equal to 1 when x is equal to 0. So times 1 times e to the 2 times x is 0 times 2. So cosine pi is -1 times 2 times e to the 0, that's 1, times 2, that's -4.